square. Okay? So let's see if it makes sense. Let's see if it makes sense. If you're over here, you have very high MSE. Should you do intra or inter? MSE already takes into account the reference, okay? So high MSE means you search, right? But the end result is pretty bad, okay? So in that case, you should do intra, correct? Okay? What about here? What about in this area? Why should you do inter? Oh, low MSE, right? Low MSE means you do very good motion estimation, correct? Then you should do inter. Now, the slope is not a straight line, but it's going like that because the variance tell you how complex the block is, right? The variance tell you if the block is smooth or the block has a lot of texture, okay? And typically, with a texture block, it's a little harder to do motion estimations, right? Because you have to match all the texture, okay? So that's why experimentally it has been confirmed that if you use this line here, you tend to do slightly better, okay? So the low energy, the high energy is the scene change. Occlusions means something that come into the frame and cover up some of the background. Uncover area means an object that moves away, that leaves the background exposed. Okay, those are scenario where you need to use intra mode. Okay, and the scenario where you need to use inter mode is when you have stationary background, you have low energy, you have translation and motion. Now, doing motion compensation or no motion compensation. No motion compensation means that you just copy the block over, right? Copy the block over, and again, this happens when the committee discover that this is a pretty reliable way to tell if you want to do copy or not. Okay, and you should verify by yourself why this is the case. But you can, as you can see, mainly because when the okay, so this is a trade-off between BD, which is defined as the 0, 0 motion vectors, okay, and the motion vectors that are resulting from your search. Okay, so this is no motion compensation means you just copy the blocks over and you don't do anything else. You don't send anything. Okay, which is the simplest case. Okay. There's another features that 80261 has, which are the loop filter. So it's a very simple filter inside the block. So 1, 2, 1 divided by 4. Is that a low pass or a high pass filter? It's a low pass filter. It's a very good average low pass filter. Actually, it's one of the wavelet filters as well, right? The 3.5 wavelet, right? So this is you only apply this filters inside the blocks to smooth out the variations, and at the boundary you don't do anything. You do no filtering. So as you can see here, this frame without the loop filters has more locking artifacts than this frame, because I have the low pass filter that smooths out things a bit. Quantization. We studied this yesterday, and there are two types of quantization. For DC and for intra DC, which is just like image coding, right? So as the average of the block is always has a high value. So in that case, you don't need a dead zone or anything like that, right? So you just do the simple mid-rise quantizer. But for inter DC, inter means you already take into account the motion estimation and compensation. For DC and AC, we have a double dead zone to generate more zeros, and that helps compression a little bit. Okay, this is the bitstream syntax, and I'm just that's just nothing to really worry about, okay, unless you really have to implement the codec. Okay, but what it means is this. Okay, and I'll just say a few things so that you understand exactly what bitstream syntax means. Bitstream syntax means you have to be very precise. At the beginning of the bitstream, you need 20 bits. Okay, that 20 bits is fixed. Okay, and that's how a player recognizes that this is H up to 6.1, but not MPEG-4 or whatever. Okay, so we assign 20 bits to describe that this is an H up to 6.1 bit stream, and it should be right in the beginning of everything. Okay, then after that comes the picture type. Okay, another 6 bits that describe is that the beginning frame, is it an I frame or intra-coded, or is it a P frame, which is use motion estimations. Okay, so we need all these things, and they are very precise. The one in red using fixed length code. The one in red use fixed length code, meaning that for every frame, for every layer, it's always use the exact same amount of bits for the red. But the one in green means that it can vary. Okay, it varies because it depends on how well you do motion estimation, how your video behaves. Okay, so the one in green has variation in the length. Okay, the one in red is fixed, etched in stone. Okay, now the main difference between, we talked about MPEG-1 relationship to 261 before. There's an overlap. Okay, so these are the main features that distinguish H up to 6.1 from MPEG-1. And as you can see, this contains a lot of improvement. So H up to 6.1 only allows you to do SIP and QSIP. Okay, because back then we don't have fast computers, we don't have fast communication channels, for example. And if you do anything more than SIP, we cannot decode anyway. So it has no value. Okay. Now MPEG-1 is different. MPEG-1 is for archiving. We don't have to worry about communication channel bit rate, so on and so forth. Okay. We will store it on our computer. So it can afford to have higher resolution. This is always 4:3 aspect ratio, but MPEG-1 you can feed it weird sizes if you want. Okay, it takes away that aspect ratio. This one has group of picture, and this one doesn't. This one has I frame, which is intra-coded, and P frame, which is predicted, the motion prediction type of. But it doesn't have the bi-directional. It doesn't have the bi-directional. Remember, we do motion estimation in the past as well as in the future. That only exists in MPEG-1. Okay, because it's archiving, right? You already have the entire video in front of you, and so it doesn't really matter. You can always look ahead. But this is for communication, real-time communications. It's harder to buffer the future frames. So it bypassed the B frames. The target bit rate for MPEG is around 1 megabits per second. This is, as I said before, 64 to 1.9. Okay. You can only skip 1 frame or 2 frames or 3 frames over here. There's no restriction over there. This guy used integer motion estimation, motion compensation, and this guy used half pixel motion estimation, motion compensation. Maybe I should go back and talk about this real quick. This is one of the major improvement between MPEG and 261. This has a larger motion estimation, larger motion range, and the end-to-end delay here is not critical at all. Who cares? Okay? As long as we can decode fast enough, then that's all there is to it. But delay here is very critical. It's for communications, right? You don't want the other side to wait a long time to see the pictures. Now, let me go back and another concept